just going to go over that real quickly. We're going to go over what entries you need to make into your assignment sheet and what you need to submit, and then we'll be done. Okay, so today we are going to go out to our favorite place on campus, our lettered points A through F, just same location where the exercise was last week, except today we're going to measure some different angles. So let's take a look here at our 6-sided figure. And today there will be measurements taken at each of the 6 lettered points. Okay. If you were actually going outside to do this today, this would be the longest lab time-wise of the semester, because as I mentioned last week, it takes a long time to get this instrument set up, get it level, and get it over the point. And today you'd be doing that 6 times, and that takes quite a bit of time. Once history shows, but by the time you're around to your 5th setup, maybe, that you finally have the process down, and it starts getting real quick toward the 4th setup or the 5th setup. By that time, you're almost done. So that's how long it takes to get familiar with how to do the setup. So anyway, okay. So today, if you're set up at location A, you're going to measure the internal angle of the closed-sided figure for all 6 locations. So at point A, you would be backsighting point F, turning your angle to point B. So you'd measure angle FAB set up at location A. Okay, then move down to location B, backsight point A, turn angle clockwise over to point C, and you'd have angle ABC. And then do the same thing around for the final 4 setups. At point C, you'd measure angle BCD. Set up at point D, you'd measure angle CDE, and so on for the last 2. And I'm going to draw all these on the whiteboard in a few seconds. Okay. So any questions what you're doing? You're going to be measuring 2 angles again this week, just like last week. And then you're going to measure a horizontal distance to your foresight, just like last week. And I'll show that on the whiteboard. So when you're done today, if you were going to measure all this, you'd have 6 setups, 2 angles at each setup, and you would have 6 horizontal distances measured. Okay. So let's move on here. Oh, man. What happened here?
I think if you hit the arrows on the sides of the screen, I think you can go from page to page, maybe.
Where are the arrows here? Let me
like right in the middle, it looks like on my screen.
Okay. This happened last week in another section. Let me try this. Oh man. See, I don't even see any arrows on the side.
Yeah, I misspoke because those will go between documents, actually, I think.
Yeah. I should be able to okay, let's see if nope. Okay. Well, the Zoom meeting is still working. So, but I'm not able to do any functions in Zoom. So let's try this again here. There we go. Oh, temporary setback there. Okay.
Easier if you also download the document, because then you open it up in a different tab and then there's no issue with it. Because that's what I usually
Yeah, now I see the arrows on the left and the right. So, okay. All right, now I'm back to where we need to be here. All right, sorry for that. Okay, so I think I explained about everything I need to explain on CE9L Exercise 8 PDF. Let's go down to your data. Okay, so the numbers in red here are the numbers that you are going to use to prepare your assignment. You're going to use these numbers as if you went outside today and took these measurements. Okay, just like you've done every lab previous to this one. For some reason, this was drawn upside down. It's got north pointing down. North arrows never point down in engineering or surveying. They always point up or they point sideways. They never point down. So this thing should be rotated 180 degrees to give you the correct view, because you can see point D is on the left-hand side of the figure and point A is on the right-hand side. But just recognize that when you prepare your assignment, don't mistake location B for location C. Don't mistake location A for location D. Make sure you put the angles, make sure you draw them and enter them correctly when you are preparing your assignment. Okay, so don't get confused because this thing's upside down. Okay, so there's the two angles that you measured for each of the 6 setups, and it's got the horizontal distance that you measured between each of the points. Okay, I don't know if these numbers are the same as far as distance FA and distance BA from lab 7. Let me look real quick. Okay, last week AE was 274, 976. And wait. Yeah, these are different. So these distances that are shown here, like for AF and for AB, are not the same as the numbers we gave you last week for lab 7. So make sure you use the ones right here on this handout. Okay, any questions on that? Or any questions what you're doing so far? Okay, all right. I'm going to load the to another file here, the lab manual pages. Exercise 8, lab manual pages. Okay, and rather than trying to tell you some of the changes verbally, I actually wrote these things down here. So let's start on the right side. Again, equipment this week is total station, clearly shown over there on the right side of figure 8-1. Okay. This week, you're going to put your measured distance in the column, the very first column that says distance. Okay. And that's the appropriate distance that you will measure when you're at angle A, measuring angle FAB. You're going to measure distance AB, the foresight, just like last week, okay? The lab manual didn't show the summation symbol at the bottom. You need to show the sum of your unadjusted or your mean angle, and then the same thing for your adjusted angle, just like last week, okay? I crossed out the allowable error. That just seems kind of irrelevant to what we're doing here for a academic type setting. It's not real life, so why bother? Why even make you do it? So just realize that that's not something you'd have to do if you were to go out and measure these distances and angles today, okay? Today, your summation of your angles should sum to the formula shown in the, which I've crossed out, for a traverse like this, where you're measuring internal angles around a closed-sided figure. The formula for your summation is n minus 2 times 180, okay? That's wrong. N's not 4 today. N is 6. So 6 minus 2 is 4. That's what I got messed up there. So it's N's your number of setups. You subtract 2 from that. We end up with 4. 180 times 4 equals 720. So your mean angles should be close to 720, and your adjusted angles should be exactly 720, okay? So any questions what you're entering here on figure 8-1? Okay, there's just one more page today. You'll start with 2 blank lab note sheets, and we're not going to mess around with these other distances like we did last week. So I've crossed out everything on the left side of figure 8-2. You're not going to compare what we gave you here to lab 2 and lab 7 again, because it really means nothing to you because you didn't physically take those measurements. So you can't look at it and say, hey, we really screwed up on that one. These numbers aren't close. Well, it's irrelevant because the numbers were given to you. And they're asking you on the top data table here to enter the same stuff you already put on figure 6- or 8-1. So we're just not going to bother with anything on the left side of figure 8-2. I crossed it out, leave the left side blank. Then on the right side, I'm going to draw a sketch very similar to what you did last week. You're going to enter your adjusted angles at the 6 lettered points, and you're going to enter the distances measured around the perimeter of the 6-sided figure, okay? Any questions on that? Okay, that's really all I have to show you. Let me go to the whiteboard real quickly. I told you this would be a short meeting today. Okay. Let me see who was late here. Okay. Okay. 1 and is here late. 2. I think that person has dropped. And okay. All right. Sorry about that. Okay, let's get over to the whiteboard. Couple things I want to talk about that I should have talked about last week, but I did not. So I apologize for that screw up. So I'll talk about it now. I might have mentioned this in your section, but I know I did mention it in all 5 sections that I'm teaching. So if I've already discussed this, this will be quick. When you're writing down angles that you have measured, okay, let's just say 16 degrees, 7 minutes and 3 seconds. Okay. 16 degrees. Don't write it like this. No, write it with the extra zeros so I can tell that it's 07. That's not so much. That's not 70. So that the 7's not a real concern, but 3. I need to know if that's 3 or 30. So make sure you show 6 digits. 2 for the degree, 2 for the minute, and 2 for the second. Okay. Also, when you are when you calculate the amount that you need to adjust for each angle, so that's after you sum your angles, you take the distance. I'm going to use last week as an example from 360, and I think you came up with 1 minute. And let me look at it real quick. Okay. Yeah, you had to adjust by 14.4 minutes. Okay. Some of you used the decimal in your adjusted angle column, which is fine, because when you sum all the decimals on all 6 of the adjusted angles, you're going to end up right at 360, 0, 0, 0, 0. Everything's going to zero out when you're done. Now, I don't know if that is going to happen this week, because I haven't really checked to see what the final results are going to look like. So in other words, the answer key, I haven't done that yet. And some of you rounded to an even number, but you made sure that you adjusted the proper amount of well, if you take 14.4 times 5, yeah, because your total error was 1 minute and 12 seconds, or 72 seconds. Okay. Some people rounded, like they put 20 seconds in one column, 25 in another. I'm not explaining this the correct way here. If you decide not to show the decimals in the adjusted angle column, if your sum comes up to 360, 0, 0, 0, 0 point whatever, that's fine. But try to use the decimal, try to show the decimal, if there is one, in the adjusted angle column, rather than rounding it from 14.4 down to 14. All right, because then you're not going to sum to 360. So use the decimal when you add it, and just show it what you come out. You know, if it's over 360 or under 360, isn't it the sum of the adjusted angles? That's fine, because it'll just be a decimal. It won't be anything higher than 1 minute. It'll be less than 1 minute. Okay, everybody understand that? Okay, so I'm just going to quickly draw here. What we're doing. Okay, you're set up at A. You're going to back sight point F, and you're going to measure an angle over here to AB, your foresight. Okay, and you're going to do that twice, and you're going to measure this distance. Okay, over here, you're going to back sight A, turn angle ABC twice to the foresight, and measure your distance B to C. And then the same thing all the way around. This angle, this distance, this angle twice, and your distance, and then this angle 2 times, and your distance here. So you should come up, oh, then point F, can't forget that one. EAF, two angles and 1 distance. So you should come up with 1, 2, 3, 4, 5, 6 distances around the perimeter of the figure, and you'll have 2, 4, 6, 8, 10, 12 angles. Okay. Any questions at all? What's your the contents of this lab this week? Pretty much the same thing as last week. Okay. So next week, we're not going to go to lab 9. We'll do that later in the semester. We're going to skip 9 and 10, and we're going to do lab 11 next week. That's the last week where we're going to be involved with any measurements with any instruments would be next week. So in preparation for the Zoom meeting, don't read lab 9, read lab 11. There are some confusing sketches in there. Don't pay a lot of attention to trying to follow the sketches in the lab manual. I'm going to give you a handout that is a photocopy of the exact same exercise that we're doing in lab 11. There's a sample in your textbook that I am going to photocopy, and we're going to follow that format because it's a lot easier to understand, and it's a lot easier to try to show you how to do it. Okay. So lab 11 next week instead of lab 9 next week. Okay. Okay. Any questions about anything? Okay. If not, we'll talk to you next Thursday. Bogdan, stick around. Everybody else, you're free to log off unless you have a question, and I will stick around for a bit until everybody's logged off. Okay.
Thank you.
Professor,
Yes.
are you gonna be able to regrade the lab?
Be able to what?
Regrade the lab, the one I sent over the email?
Is this Jagan I'm talking to?
Yeah.
Okay. You emailed it, right?
Yeah. Right after
Yeah.
class last week.
No, some people have had trouble with Canvas, or they are submitting late, and Canvas won't let you submit anything a certain time frame after the due date. So you're forced to use email. And to be honest with you, I haven't graded any of those assignments that have been emailed to me yet. There's not that many. I'm going to try to get all that done this weekend and get caught up. But yeah, I will take care of that. That's the email submittals kind of have a low priority because it takes so much time just to grade stuff on Canvas, especially with Canvas not performing really well here. It tends to disconnect itself quite often, and it's very frustrating when you're doing the speed grader on there. But anyway, regardless, I'll get to it. That's all I can tell you.
Okay, just making sure.
Okay.
Thank you.